Okay, welcome back. In this video, we're going to talk about logical operators. Logical operators are a key piece of being able to write effective programming logic. And this is going to allow us, as we start moving forward in the course, to be able to write more sophisticated programs that have more sophisticated code, more sophisticated logic, and make it do more interesting things. Okay, well, logical operations, they're all dealing with Boolean information. Okay, and the result of that then is that we're going to have a true or false conclusion. Okay, so let's take a look at this. Let's just take a look at the AND operator, for example. Okay, and what we're really seeing here is an equivalent of a truth table if you've seen that somewhere else in the past. And the AND operator only results in true if both of the inputs are true. Okay, and this makes sense even just from everyday English. If you think of so in this case, A and B are true. If A is true and B is true. So you think about it, if you used, if you used a statement in everyday English and said, "Oh, my name is John, and I am teaching programming for engineers." Okay, so that's two true statements will result in a true output. Okay. If I said my name is Fred and I'm teaching programming for engineers, one part of that statement is false. It negates the entire thing. It makes the entire statement false. Okay, so the only time an AND operator results in true is if both propositions, if both inputs are also true. Okay. When in doubt, think back of just real life examples of what you're used to every day. The OR operator is different. The OR operator is true if any one input is true. It's only false if both inputs are false. So the same example as before, right? If I said my name is Fred or I'm teaching programming for engineers, well, that's still true because it only requires one of the two inputs to be true. So in that case, they're only false if both inputs are false for the OR operator. Okay. And the NOT operator, the third one we want to look at here today, is very simple. We're just swapping whatever the input is. If it's false, it goes true. If it's true, it becomes false. Okay. So let's look at how we actually do that in the context of an example here. If we throw in some real numbers, here we look at the example and we say, let's assume, we're going to assume this up here. We're going to assume that x is 7 and y is 9. And if we look at that, right, we say, okay, if x is 7, well, 7 is greater than 0, so that's true. All right. And y, 9, is less than 10. So that's true. True and true is true. Okay. If we look down here, right, we said, okay, 7 is greater than 0. That's true. And 9 less than 5 is false. True and false is false. Okay. If we go over here, right, we're looking at the OR operator. If we say 7 less than 0 is false, or 9 greater than 10 is false. False or false is false, right? And then 7 less than 0 is false, or 9 greater than 5 is true. False or true is true, okay? And then if we say 7 less than 0 is false, but not false is true, right? 7 greater than 0 is true, not true is false. Okay, so it's just the basic examples of using this in practice. I could show you an example here. Here's an often way in which this takes place is a concept called range checking. Range checking. If I come here, I'm going to write some simple code. Okay, and let's say I want the user to enter a number between, let's say, 1 and 100, and we'll assume it's inclusive. It could be 1 and 100 will count. Okay, I could check. Well, we'll do num Okay, and I could check here, right? So now I'm getting a user to enter a number, and I could say, well, wait a minute, is it in fact greater than 1, greater than or equal to 1, and is num less than or equal to 100? Okay. If so, it's a valid number. Okay, I could do that. Okay, this way, if the user enters something that's outside of those bounds, it will say something. It'll actually, in this case, it'll say nothing. We can make it say something. Okay. So we could do something like that. That's referred to as range checking. We're checking that the inputs make sense. It's somewhere in a range that we want. Okay, so if I typed in this case, 230, that's outside of the range. It's going to say it's not a valid number. Okay, and we could also do this in such a way, we could even do, make it a little bit more sophisticated. We could do something called as we've seen before, an example of a do while loop, where I can continue asking the user to effectively continue to enter a number while we are not in that range. Okay, so for it, we'll actually flip it the other way around, that if the user enters something less than 1, okay, or greater than 100, we're going to keep asking them for the number. Okay, so what this will do is, think about the logic here. Okay, think about the logic. If what's going to happen with the do while loop, right? We're going to come in here, right? We're going to ask the user for a number. They're going to enter a number. If the number is within that range of 100, like let's say someone enters 50, okay? 50 is not less than 1, okay? So that's false. 50 is not greater than 100, so that's false. False or false is false, and we leave, right? We're going to leave that loop because it's a valid number, right? And I can even maybe make that a little more clear. We'll write something here. Okay. Likewise, if somebody enters, say, 230, 230 is greater than 100, true ORed with anything is going to be true, and it's going to continue asking the user over and over again until they enter a valid number. Okay, so that's what's going to happen in this case. So if I run it, so this is an example of these types of range checking with the logical operators in action. In this case, if I enter an invalid number, it's going to continue to ask me to enter a number until I enter something that's within the range, and then it says it's valid. Okay, so this is an example kind of combining a few things that we've learned thus far. Okay. Now, as you saw me do, I kind of gleamed over it, is the double ampersand is the AND operator. Okay, so I don't actually write the word AND in C. I do it with the double ampersand. And I don't write the word OR in C. I do the double vertical bars. Okay, a not operator would be with the exclamation point. Okay, so I'm going back to that example here. Here I'm using the OR operator. Right? If I had the AND operator, it would be 2 ampersands. Okay, it depends on what you want. If I wanted to say not something, right? I could do that as well. For instance, if I had this case that maybe I had the logic that's within the range. This here is kind of the opposite of what I want, right? We're saying if the number's in the range, and I could say, well, I'm going to put parentheses around this whole thing. Oops. I'm putting parentheses around this whole thing, and I'm saying not. Okay, it should do the same thing as before, right? Using the AND operator here. So let me recompile and run that. Okay, we'll do 230, negative 32, right? 987, 56. Okay. Same, it did the exact same thing. But this is an example using the not operator. What this is effectively doing is you could think of it, it's like, here's our range, okay, and I want to continue looping while the number entered is not, the exclamation point is the not in that correct range, okay? So it's equivalent to what we did previously with the OR operator. Okay. Let's take this a little bit further, right? Let's look at another example here, or another couple examples. Let's now assume that we have num people equals 10, and we're going to have a character here. This is going to be of type char, character that's going to be Q. And let's say, well, what happens in this case here when we have these examples? Do these expressions evaluate to true or false? Okay, do these expressions operate? Do they end up being true or false? Okay, so num people, that value is 10. We say, is 10 greater than or equal to 10? That part's true. Okay, and then we're saying, is user key, which is the character Q, we're saying, is that equal to X, which is false? And if we have true and false, is a false statement. Okay. So once again, down here, num people is 10. 10 greater than or equal to 20 is false. Okay. User key is Q. Q equal to Q is true. Okay. False or true is true. Right? Because of the OR operator, it just has to have one of the two have to be true. Okay. Down here, right, user key Q, does Q equal A, right? That's false, but we have this not operator. Okay, not false equals true. Remember, exclamation point stands for not. Okay. And then down below, num people 10. 10 equal to 5 is a false statement. 10 equal to 6 is also a false statement. And then, so we're effectively simplifying it to this. Okay. False or false is false, but not false is true. So that's a true statement. Okay. There is a particular order. I'm not going to get carried away with this. This is stuff that's super easy to look up and is kind of ridiculous to memorize in a way, especially when you're early on doing this. I'm just going to point it out and then kind of move forward. When you could build long expressions to evaluate true or false as part of your logic in your code. That's what really programming is. It's logic. It's problem solving. You can have, sometimes expressions can get somewhat long. There is an order of operations and how these are evaluated. There's a couple of key things to remember, and the big one is kind of the obvious one, is that parentheses are operated on first, right? They take so when the general rule I would say is, when in doubt, use parentheses, okay? You don't want to make your code somewhat ambiguous or hard to understand, right? You don't want people guessing and trying to have to look things up, whether yourself or somebody else looking at your code. So when in doubt, just be clear, be explicit, just use parentheses. That's my general advice. So parentheses have the first, right? Exclamation point would be the second in the operations. Then arithmetic operators are going to follow similar order of operations that you would be used to, right? With say like the multiplication happening first and division, etc. And I won't go through the whole list, but the general rule would be, if you're not sure what's operated in what order, just use parentheses, okay? It doesn't hurt. And then one last thing to point out here is that your code is optimized. When you're running your programs, it doesn't waste time on things that are unnecessary. So let me just kind of point this out, that if we have an AND operator here, right? And one of the operands is the one on the left, if it's determined that that's false, right? This one here is not even checked, okay? Right? Because if someone tells you this, false and something, right? What's the answer? False and something. You don't need to know what that other thing is. It's irrelevant if it's true or false, right? The second operand, it's irrelevant. False and anything is going to be false, right? So it's irrelevant, and therefore it's not even checked. Okay, that actually could be a helpful little trick sometimes, because you can have something in the second operand that would cause an error if it was checked, dependent on whether the first thing was false or true. And you can kind of exploit that. This is a minor point. This is a very minor point. I'm going to kind of go over quickly and then wrap that up. It's kind of does the opposite. If it's an or operator, if it's true, the second operand isn't checked. The reason being true or anything is going to be equal to what? Well, we know that's going to be true, right? It doesn't matter what the second thing is. So there's just no reason to check it. Okay, so it's actually even skipped. It's not even looked at. It's not, that expression's not even evaluated after that. Okay, minor point. Okay. So just a couple practice questions, and then we'll call it a video. This is saying the first one here. What value of x results in a short circuit evaluation which skips evaluating the second operand? Okay. Well, so it's saying, under what conditions would we not run this here on the right-hand side, the second operand? Under what conditions, right? And because it's an and logical operator, that's the condition in which the left operand is what? And that would be false, right? So which of these choices down here represents when it's going to be false? Right, and there's only one, which is greater than or equal to 4, and that's this, 6, out of the choices provided. So 6 is not less than 4, it's false, right? False, and did anything is going to be false. This is not even checked. It's irrelevant what that is there, okay? Doesn't matter, okay, when x is 6, okay, or greater than or equal, anything greater than or equal to 4. Okay, last one here, same thing, right? What value of y results in a short circuit evaluation which skips evaluating the second operand? Which one's going to skip this, right? We have an or operator, so that's the condition that makes this left operand true, right? True, which is going to be 3, right? If it true or anything is true, this one is irrelevant here, okay? Logical operators are used all the time. They're used constantly. You're going to use them throughout the course and through your academic career and beyond. Okay, these are just a constant way in which things operate, including they come up even in terms of logical operands is a key part of digital electronics. When you do some digital logic and take some courses that emphasize that, you'll see that that's a critical part of how circuits work as well. Okay, so thanks for watching, and we will follow up using these and practicing them in class.